Hello, 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 everybody, and welcome back. We're looking at question number 24 on the 2008 Grade 7 Gauss paper. And what have we got? A star is made by overlapping two identical equilateral triangles as shown. And so just stopping, finishing, before I finish reading the question, what have we got here? Well, we've got two triangles, one of them shaded. I'm going to guess this is a find the area, the shaded region question. Very particular note that all these lengths with a dash through them are the same. They are the same length, whatever it may be. The entire star has an area of 36. What is the sum? What is the area of the shaded region? Okay. So the shaded region is just one of the triangles. One of the big triangles. Obviously, there are lots of little triangles. Now, what can we do here? Well, I suspect the fact that they've told us that all those lengths are the same, and the fact that we're talking about two identical equilateral triangles, my guess is there's going to be a lot of similar sides, a lot of congruent sides, so same length, and a lot of 60 degrees. So what I would do is I would start by drawing a big version of this picture and just figuring out where are all my equilateral triangles, because I suspect there's a lot of them. And that big hexagon in the middle, I think, can be broken down into equilateral triangles as well. But let's not get ahead of ourselves. So we'll go over to the notepad, and we will draw our picture. Doesn't have to be super exact. I know this doesn't look equilateral because these aren't equilateral, but we can pretend, can't we? Alright, so dash, 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 dash. Alright. Now, the big triangle is equilateral, so I get 60 degrees in every corner. Okay. But if I just take a look at one of these small triangles, it's isosceles, right? So because we've got the same sides here. And that means the angles in the corner are going to be equal. So two of these angles in the corner plus 60 degrees has to add up to a full 180 degrees. It's not that hard to work out that the angle in the corner is going to be 60 degrees as well. So that tells me these angles are 60 degrees, these are 60 degrees, 60, 60, 60, all over the place. But if these are all 60 degrees, that makes them equilateral triangles, and so this length is the same all the way through. Okay. So, lots of equilateral triangles here. And the shaded region is this triangle up here, this triangle down here, this triangle down here, and the whole hexagon. Now, the question is, can I figure out the area of the hexagon? And actually, we can. So, well, let's talk briefly about this. What I'm going to do is I'm going to switch to, let's say, purple. I'm going to connect up opposite corners of my hexagon. And look at that, we get a whole bunch of triangles. Now, what could we say about these triangles? Well, I suspect they're all equilateral. I need a way to sort of confirm this. Let's see, we've got 60 and 100. This is 120 degrees here. Now, it's not enough just to say I think this line splits, because it might not, but these all should be the same triangle, so it should be fairly straightforward. And some other people out there might be seeing this faster than I am. I'm not exactly seeing. Okay. Here we go. So now that I've drawn that, I have this green triangle here, but look at these side lengths. It's two copies of the small dash, so it's isosceles. So we have a 60 up here from the smaller triangle, and that tells me these are going to be 60. And from there, we can do things like, well, then this must be 60, because in total it's 120, because we have a full line here, So 60, 60, and there's going to be 60s all over the place, and so all of these are equilateral, so they're all the same triangle. Okay? This didn't matter so much. Like, if this were a written contest, you'd actually have to show, say something like, why are all these triangles the same? Which is why I stopped and did it. But if you just realize, well, it's going to be a regular hexagon, so let's cut it up into 6 of these same equilateral triangles, that's fine. It's a multiple choice contest. You don't have to show your work. I'm trying to explain it, so I do have to show my work, at least to you. Okay? But what have we got? So just to draw the picture again a little simpler, we have the shaded area is made up of 1, 2, 3, 4, 5, 6, 7, 8, 9 triangles. And then we have 1, 2, 3 more, so 12 triangles is the total star. Now they told us the star has an area of 36. And so each triangle must have an area of 3. So the shaded area, which is 9 triangles, must be 9 times 3, or 27. Okay? Is 27 one of our possible answers? It certainly is. It's right there. So C is going to be our answer for 24. We've got one more question to go. That'll be question 25. I will see you guys for that next time.